In today's lecture, we are going to learn machine-dependent code optimization. And in this machine-dependent code optimization, what is the meaning of register allocation? So we understand with the help of an example. I am taking an example. Suppose R1 is equal to B plus C. We are defining R2 is equal to R1 plus F. And we are writing R3 is equal to R1 minus R2. So here, how many registers we are using? 3 registers we are using, R1, R2 and R3. So here we are able to see that we can reduce this R3. So how we can reduce, or we can say minimization of register entries. So what is the solution for that? The solution for that is we can define like this: R1 is equal to B plus C, R2 is equal to R1 plus F, and instead of R3 we can write R1 only. R1 is equal to R1 minus R2. So here we are able to see that minimization of register entry is there in register allocation. And the next one is use of addressing mode. So what we can do in that, so this is the same like removal of unreachable code that we have learned in the last lecture. So again I'm explaining with the same example. Suppose we have define wwatch 0 if batch is there. If wbatch is there, so it will print go to, else it will print not go to. So we are able to see that because already we have defined 0 value, so this is okay. It is not required because it will not go to this side. So we need to use the addressing mode like this. So for this solution is what we need to write only printf go to. So this is the solution for that. So this is all about the register allocation and use of addressing mode in machine dependent code optimization. If you like it, share it, subscribe it, comment below. Thank you.